Lead is a toxicant that impacts multiple body systems affecting all ages, genders, and races. It is omnipresent in extensive parts of our environment. A decent amount of our exposure comes from the use of fossil fuels, including the use of leaded gasoline, industrial factories, ceramics, and even batteries. The toxicant is very detrimental for the human body because it interferes with numerous enzymes inside the cells of our needed organs. This particularly affects the brain, liver, kidney, and bones. Over time, lead is stored in the teeth and bones where it accumulates, and lead exposure mostly occurs from ingestion or inhalation, and this is usually from deteriorating lead-based paints in houses. In terms of who's more affected by lead between children and adults, children are more prone because of their growing bodies that absorb more lead than adults do. Their brains and nervous systems are more sensitive to the damaging effects of lead as they are not fully developed. Adult brain growth is stopped naturally by the mid-20s and therefore only face the threat of kidney deterioration or failure, except with the exception of pregnant women who can also face many more risks. A pregnant woman's exposure to lead is of particular concern because they can cross the placental barrier, which results in exposure to a developing baby. Symptoms of lead poisoning include developmental delay, learning difficulties, irritability, loss of appetite, weight loss, sluggishness and fatigue, abdominal pain, vomiting, constipation, hearing loss, and lead-induced seizures.
As stated before, children are the most vulnerable as they ingest 4 to 5 times as much lead as adults and don't have fully developed brains. Studies have even found that undernourished children are far more susceptible due to the lack of nutrients in their bodies. When exposed to high levels of lead, the brain and central nervous system will be attacked. This is because lead disrupts the movement of storage calcium ions within cells, increasing cell stress, which results in the death of brain cells and neurons. Child survivors are usually left with intellectual disabilities and behavioral disorders, which are believed to be irreversible. It is also possible for lead to affect a child's brain development, resulting in a reduced IQ, changed social patterns, reduced impulse control, or aggressive tendencies.
The result of reduced impulse control or aggressive tendencies have even been hypothesized to be linked to criminal activity. One proposed idea is a connection drawn between childhood exposure and future brain development. Increased lead in a child's blood levels have been linked to reduced brain volume as an adult, the effects of which are seen in the prefrontal and anterior cingulate cortices. This links to crime because these areas of the brain play an important role in controlling mood and decision-making, so this affected brain is left with reduced impulse control and aggressive tendencies that result in the brain being more inclined to criminal activity than the normal brain. A similar theory also proposed is the neurotoxicity hypothesis, which further proposes that lead interferes with neurotransmitters and hormones in a way that contributes to aggressive and violent behaviors. Some steps have been made in terms of reducing lead exposure in daily life, but there's still much more to be done. Thank you so much for listening.